Welcome back to Scepti Cosmos. Today we're on another adventure, guided by our curiosity and our mission to unveil the mysteries beyond belief. Let's dive in. When we gaze up at the night sky, we see a vast expanse dotted with countless stars. But there's one star that has been the subject of intense scrutiny and fascination, and that is Betelgeuse. This red supergiant, settled in the constellation Orion, has been a cosmic spectacle that challenges the very fabric of our understanding of the universe. But what scientists have just discovered about Betelgeuse is nothing short of insane. NASA's Hubble Space Telescope and other observatories have been keeping a close eye on Betelgeuse, and what they've observed has left even the most seasoned astronomers with chills running down their spines. In 2019, Betelgeuse did something extraordinary. It blew its top, losing a substantial part of its visible surface in a gigantic surface mass ejection. This event was unprecedented and left scientists around the world scratching their heads. As scientist Dennis Overby put it, Betelgeuse, to put it most politely, burped. Massive stellar eruption was unlike anything we've ever seen before, but the mystery doesn't end there. The aftermath of this event has led to even more puzzling observations. In the months following the massive eruption, Betelgeuse began to dim. This phenomenon, known as the Great Dimming, was so significant that it was even visible to the naked eye. Imagine a lighthouse, its beam cutting through the night, suddenly dimming to the point where it's barely visible. That's what happened to Betelgeuse. But why did Betelgeuse dim so drastically? What could cause such a dramatic change in one of the brightest stars in our night sky? Scientists believe that the dimming was caused by the star's massive eruption. The surface mass ejection released a cloud of dust and gas that obscured Betelgeuse's light. But as one scientist noted, to cause Betelgeuse's dimming, a star spot would have to be enormous. This suggests that there's more to the story than we currently understand. The great dimming of Betelgeuse was just the beginning. The star's behavior continued to baffle scientists when it experienced a massive stellar eruption. This eruption was unlike anything we've ever seen before. It was so powerful that it caused Betelgeuse to lose a significant portion of its mass. Scientists are still trying to answer these questions, but one thing is clear: Betelgeuse is a star like no other. The James Webb Space Telescope, NASA's most powerful and advanced space observatory, has been instrumental in studying Betelgeuse. The telescope's findings have been nothing short of groundbreaking. It has provided us with a unique glimpse into the life of this extraordinary star. According to the data from the telescope, Betelgeuse is slowly recovering from its massive eruption. But the recovery process is far from ordinary. The telescope has detected infrared light from the ejected material as it moves away from Betelgeuse. This suggests that the star is still undergoing significant changes. So, what's the real story behind Betelgeuse's recovery? And what does it tell us about the life cycle of stars? The erratic behavior of Betelgeuse has led some scientists to make a bold prediction. Betelgeuse could go supernova. A supernova is a powerful and luminous stellar explosion. It's one of the most violent events in the universe. And if Betelgeuse were to go supernova, it would be a sight to behold. But when will this happen? And what will it look like? Scientists believe that a supernova could happen within the next 100,000 years. But in astronomical terms, that's just a blink of an eye. But now, researchers from Tohoku University in Japan and the University of Geneva in Switzerland have recently reassessed oscillations in the brightness of Betelgeuse. Their findings suggest that these oscillations likely represent the very end stage of the star's life. Betelgeuse, once a hot heavyweight beast known as an O-type star, is already a bloated red ball of gas running low on fuel. Its years are numbered, but just how numbered depends on a bunch of factors. The researchers behind this latest investigation argue that the thermodynamics behind oscillations in luminous supergiants like Betelgeuse are a little more complicated than in most other stars. If the star were squeezing atomic nuclei into slightly larger elements such as carbon, it just might manage a much longer radial pulsing period. The team showed how the longer pulse would be consistent with a radius of around 1,300 times that of our Sun. That means the outer layers of Betelgeuse are drifting much further away as its mass concentrates in its core, churning through fuel at a rate fast enough for its engines to seize not in millennia, but in decades. If the model is correct, we could watch Betelgeuse briefly outshine all other stars soon after the middle of the century before it fades from its constellation forever. Of course, there is sure to be continued debate over the details of Betelgeuse's true size and proximity to death until it does finally go pop. If you enjoyed this journey through the cosmos and want to keep exploring with us, don't forget to hit the like button and share this video with your fellow space enthusiasts. And if you haven't already, make sure to subscribe to Scepti Cosmos for more fascinating insights into the universe.